Hello everyone and welcome to the channel. Today we're going to do the first video of the seismic gap series, and in this first video we're going to cover the region of Alaska and the Pacific Northwest here in Canada, and we're going to talk first about the tectonic setting, then we're going to see where the main fault lines are and where the seismic gaps are going to be found. So, first here we have the carpet of the continental seismic gaps, and I'm going to show you here the different fault lines. But before, we're going to talk about the tectonic setting of Alaska region as a whole and the Pacific Northwest. So, in basic terms, this region of the world is dominated by the Pacific Plate here, which covers the whole Pacific Ocean, and the North American Plate here, which covers from Alaska to all the way down to Mexico. So in this region we have the subduction zone here of Alaska and Aleutian Islands, and this part of here, the movement of the plates starts going from south to north, now in a northwest direction of the Pacific Plate. So the plates are sliding here past one another. The result of this is many strike slip faults in here. This is the Denali mountain peak, the tallest mountain in the North American continent. And the fault continues here, and there is also like this very long one continuation of the fault line here. And there's the Fairweather Queen Charlotte fault, which runs offshore here in the Pacific Ocean, all the way down to the Cascadia subduction zone, which starts right here in southern western Canada. So the main fault lines are the Denali fault and the Fairweather Queen Charlotte Islands fault line. We're going to start with the Denali fault line here, which of course by its name means it starts here around the Denali Peak area, which is consistent of constitutional about 3 segments, which constitutes and mainly 3 segments. We have the West Denali segment here, highlighted here in yellow. We can also have the central segment, which runs all the way down here into Canada, and we also have the East Denali segment, which runs through this icy bay, I think it's called, or sorry, mud bay, I was mistaken. And there's also another feature, another splay fault, as you may see sometimes called, which is the Totshunda fault, which runs here from the central part of the Denali fault all the way down to the Hubbard Glacier region. So this is the main part of the fault line, which is dominantly strike slip motion. So here is when we talked about earlier, the Pacific Plate is pushing towards this direction, and the North American Plate is also in this direction, but it's kind of rotating. So the fault line accommodates this motion around the interface, and it's a strike slip motion. So what do we have here exactly? So as you can see from satellite image, you can see the fault line like pretty clearly, more or less, between the mountains and the glaciers. And this was the site of a maybe well-known earthquake, at least in the North American people, which was the Denali 2002 earthquake. The earthquake, it didn't start in the main Denali fault line, but in a thrust fault here at the south of it. It was a complex rupture which involved the rupture of many different faults. In this case, it was I think three different faults, which is this one, a thrust fault, And then we have the central region of the rupture here, and then we also have the Totsunda fault, which ruptured partially only the northern part of the fault line and at the southern end of the Denali rupture. So basically here, this is the rupture of the 2002 Denali quake. So as you can see, there are not any other recorded earthquakes here because it's a very remote region, and the whole eastern part of the Denali fault line hasn't had an earthquake in recent times. The same goes for the western part, although there's also a probable event here around this area. I'm going to show you with the rule. There was a rupture around this area, right in the Denali region. But this event is not very well known. It was in 1929, I think it was, and its magnitude is estimated to be at least magnitude 7 or maybe higher. But it's nowhere near close the rupture of the size of the 2002 Denali quake, which was very long rupture and a very complex one with a lot of displacement. I think it was 386 kilometers in total ruptured the three parts of the three fault lines. So a clear seismic gap can be stated that it's between the 1929 rupture in Denali and the start of the 2002 rupture, which is mainly this part here. And as you can see, this part will be around more or less 183, 184 kilometers long, which is more than enough to have a big magnitude 7.5 or higher earthquake here in this section. There is not many studies of paleoseismic here, but the recurrence time of these types of events are in the hundreds of years, because the Denali fault line is not very fast moving, and this part of the fault line slips at about I think it was 11 millimeters per year, same in the central part. The eastern part, this part is very tricky because the fault line starts to fall off. The slip rate, that is the motion that is accommodated in this part, starts to decay at around, I think it was 3 to 5 millimeters in the southern part per year, which is a lot slower than in the eastern and central part of the fault line. And all this motion that the Denali fault doesn't have starts pushing in the Totsunda fault here, which ruptured in the 2002 earthquake here, this part. So more or less the seismic gaps here could consist of the whole eastern part here, sorry, I meant to do this, the whole eastern part here of the Denali fault line can fail, and it's a very long one, distance almost the same as the 2002 earthquake in Denali. And there's also this section of the Totsunda fault that didn't rupture in the same earthquake, which could have another significant rupture, as the slip rate in this fault is a lot higher than in the eastern part of the Denali fault line. So we have finished the Denali fault, and we're going to do now the Queen Charlotte Fairweather fault line. The Queen Charlotte Fairweather fault line starts in the southern part of the Totsunda fault, but it's connected with a newly discovered fault line, which is called the connector fault, which runs through here. It's a very understudied fault line, and we in the present don't know exactly how it works, but we know it's there because in 2025 we had the Hubbard Glacier earthquake, which ruptured the middle part of the fault line. I'm going to show it here. It ruptured in the center of the connector fault line, so it basically means that this fault line exists, and it connects the motion of the Totsunda fault to the northern segment of the Fairweather fault. So where does it start? It starts mainly here, the northern segment. There's a step over here, and the northern segment goes all the way down to the Chichagof Island, and the central segment here, it goes to the southern tip of the same island. It now goes offshore here in the ocean, and there's the southern segment which goes through the southern tip all the way to the Cascadia subduction zone. And this is the Graham Island and the Queen Charlotte Island region. So that's what is called the Queen Charlotte or Fairweather fault line. So this fault line is very active. It accommodates almost the entire motion of the Pacific and North American plates. That is almost, I think, 5 centimeters per year, or 50 millimeters per year, as compared to, that's 5 times more than the Denali fault line and the Totsuda fault. And it basically means that regular, very big strike-slip earthquake happen in this fault line. The first of which happened in 1949 in the Queen Charlotte Island region, which ruptured this part here. Which ruptured this part here in the middle section of the central southern part of the fault line, and the rupture was around 500 kilometers long. That is a very long distance, and the magnitude of this earthquake was around 8.1 or maybe even 8.2 in the moment magnitude scale. But it did not cause, I think, at least that I know of, any fatalities, because it was in the ocean, and it caused a very strong ground motion here in this part of Alaska and Canada, but it did not kill anyone, I think, or cause major destruction, because it was basically offshore. There was also this 1958 Lituya Bay earthquake, which happened here in the northern section, and this one is very famous because it caused a mega tsunami here in the Lituya Bay. This is the Lituya Bay, as you can see right there, and it caused the landslide here, which caused a mega tsunami in the whole bay and destroyed many trees and many places here, and it did cause some serious property damage and fatalities here in this area, because it happened in maybe it's partly populated area, but there was some population here in the icy bay also, and it caused destruction and deaths. And after that one we have the first it was the 1970 Haida Gwaii quake. Sorry, I'm going to it overlaps right here. You cannot see because it was in the southern section of the Haida Gwaii region, that is this island, the Graham Island, and the rupture was in the same region as the 1949 earthquake. And last but not least, there's this 1972 Sitka earthquake, which ruptured the central segment in this Sitka island, the southern part of it. And it did not cause fatalities that I know of, or maybe it was 1 or 2, because it was also in the offshore part of the fault line. So as you can see, this sorry, I have one left. It is the 2013 Craig earthquake, which also ruptured here. I'm going to show you right now. It's here. It was also in the central part, the central segment. It ruptured part of the 1972 Sitka and the 1949 Queen Charlotte earthquake. And as you can see, there's not much time between the two earthquakes. So that means that this fault line in particular gets ready every few years or so. So that means that there is no relative seismic gap. Maybe you can say that in the southern part here there is a seismic gap, which is around more or less 170 kilometers long, which is more than enough to have a very big earthquake. So you can expect one here in the future, or you can expect another one in basically any other part of the fault line that hasn't ruptured since many decades ago. For example, the Lituya Bay segment here. So this part of the fault can rupture once again, and it's a pretty long one. You can see there's like more than 300 kilometers long. That is more than enough to cause a very strong earthquake, and maybe have a repeat of the 1958 Lituya Bay earthquake here, and maybe have some type of similar disaster to what happened in that year. So that's it for today. We saw the Denali fault line and the Queen Charlotte Fairweather fault line, and we understood that mainly the western part of the Denali, maybe the southern part of the Totsuda fault, and basically the whole part of the Queen Charlotte and Fairweather fault system can be considered seismic gaps, and we can expect in the next decades, or maybe even the next few years, to have a very long rupture. But it's not very close in time, maybe, because this part of the fault line needs a bit of loading, maybe, just maybe. Then again, there's 5 centimeters per year, so you can say that every century there's 5 meters of displacement accumulated in the fault line, and that's a lot, and it's probably the highest we are going to see in the whole series. So this particular fault is very active, the Queen Charlotte and Fairweather fault. And the next one we're going to cover is the San Andreas fault line here, which is located in this part. We all know, I think, where this is located. It's a fault line that runs through the whole California region down to Mexico, and it's very known to be a very dangerous fault line, and it's also very similar to the Queen Charlotte Fairweather fault line. So in the next video we're going to discuss about the San Andreas fault line, but for today we can conclude that the seismic gaps in the Denali and Fairweather Queen Charlotte region have been assessed, and I will see you guys in the next video, and we will cover the San Andreas fault line, as I said. So bye bye, and I'll see you next time.